Our planet is a world of immense beauty and staggering diversity. We have scaled its highest peaks and crossed its most arid deserts. We have mapped its continents and charted the courses of its great rivers. Yet, there remain places on Earth that are as alien and inaccessible as the surface of another world. Vast realms lie hidden beneath the shimmering surface of our oceans, concealed from the sun's warm gaze. It is here, in the profound, crushing blackness of the deep sea, that we find the planet's most extreme and mysterious environment. This is a world of immense pressure, of perpetual cold, and of creatures that defy our very understanding of what life can be. It is a place of humbling scale and silent majesty, a final frontier on our own world. We are drawn to these hidden places, driven by an innate curiosity to understand the full scope of life on Earth. There is one location, however, that holds a particular fascination, a place that represents the ultimate terrestrial unknown. It is a scar on the Earth's crust, a trench so deep that it could swallow our tallest mountains without a trace. This is the Mariana Trench, the very deepest part of all our oceans. To journey here, even with the most advanced technology, is to venture into a realm that has been visited by fewer people than have stood on the moon. It is an expedition, not just to a physical place, but to the very limits of exploration and endurance, both for humans and for the machines we build to be our eyes and hands. The name itself whispers of mystery and adventure, conjuring images of a silent alien landscape. The Mariana Trench is more than just a geographical feature. It is a symbol of all that we have yet to discover. It challenges our assumptions about where life can exist and what forms it might take. The conditions here are so severe, so utterly hostile to the life we know on the surface, that for centuries it was believed to be a sterile, lifeless void. But we now know that this is far from the truth. This abyss, this seemingly empty chasm, is home to a remarkable and resilient community of organisms, each one a testament to the sheer tenacity of life in the face of overwhelming odds. So, let us begin a journey together, a descent into this incredible, crushing darkness. We will leave the familiar world of light and warmth behind and venture down, mile after mile, into the heart of the abyss. We will explore its geography, understand the immense forces that shape it, and meet the strange and wonderful inhabitants that call it home. This is not just a story of a deep trench in the ocean. It is a story of discovery, of human ingenuity, and of the enduring power of the natural world. It is the story of the Mariana Trench, our planet's deepest, most enigmatic, and perhaps its most awe-inspiring secret. To find this extraordinary place, we must travel to the vast expanse of the western Pacific Ocean. Here, just to the east of the Mariana Islands, lies a crescent-shaped scar in the Earth's crust. This is the Mariana Trench. It is part of a global network of deep ocean trenches that mark the boundaries where the planet's great tectonic plates collide. The trench stretches for an astonishing 1,580 miles, or about 2,550 kilometers, a colossal feature hidden beneath the waves. But it is not its length that makes it famous. It is its staggering, record-breaking depth. This is the lowest point on the surface of our planet, a place of superlatives. Within this immense trench lies a specific, smaller valley, a slot canyon at the southern end known as the Challenger Deep. This is the champion of depths, the very bottom of the world. Its floor lies nearly 11,000 meters, or about 36,000 feet below sea level. That is almost 7 miles straight down. The name itself is a nod to history, a tribute to the HMS Challenger expedition of the 1870s, which first sounded its incredible depths and gave humanity its first hint of the sheer scale of this underwater canyon. Their primitive tools, a simple weighted rope, could barely fathom the void, but they confirmed that they had found a place of unimaginable depth, forever changing our map of the world. The formation of such a feature is a process of immense geological power, played out over millions of years. The Mariana Trench exists because of a process called subduction. Here, the colossal Pacific Plate, one of the Earth's largest tectonic plates, is slowly and inexorably being forced down and under the smaller neighboring Mariana Plate. As the Pacific Plate bends and plunges into the Earth's mantle, it creates this deep, narrow chasm. It is a dynamic, living part of our planet's geology, a place where the very crust of the Earth is being recycled. The trench is not a static feature, but a zone of constant, slow-motion geological violence. This remote location, far from any major landmass, is one of the reasons the trench has remained so mysterious for so long. It is not a place one simply stumbles upon. Reaching it requires a dedicated oceanographic expedition, a journey across hundreds of miles of open ocean. Its sheer distance from our daily lives contributes to its mystique. It lies out of sight, and for most of history, out of reach. It is a hidden world, governed by its own rules, its own timeline, and its own unique inhabitants, waiting patiently in the dark for us to find the courage and the means to visit. The numbers associated with the Mariana Trench, 7 miles, 11,000 meters, are so large that they can be difficult for our minds to truly grasp. To comprehend this colossal depth, we need comparisons, familiar landmarks to place into this alien context. Let us take the tallest mountain on Earth, Mount Everest. Its peak stands a mighty 8,848 meters above sea level. If we were to take this giant of the Himalayas and place it into the Challenger Deep, its summit would still be submerged. There would be more than 2 kilometers or over a mile of water still covering its highest point. The trench is so profound that it could hide the entirety of our planet's greatest mountain with ease. Now, let us consider something from our modern world, a commercial airliner. These machines cruise at high altitudes, typically around 30,000 to 40,000 feet, or about 9 to 12 kilometers above the ground. This is the altitude from which we look down upon the clouds, seeing the world spread out like a map below. The depth of the Challenger Deep is roughly equivalent to this cruising altitude. Imagine an airplane flying at its normal height. Now, picture that same distance pointed straight down, into the water. That is the journey a submersible must make to reach the bottom. It is a vertical voyage into a realm as far removed from the surface as the stratosphere. Even the journey of light itself tells a story of this immense depth. The sun's rays, which bring life and warmth to the surface waters, cannot penetrate this far. The photic zone, where sunlight can support photosynthesis, ends at around 200 meters. Below this is the twilight zone, where the light fades to a faint, ghostly blue. By 1,000 meters down, all sunlight is gone. The rest of the journey to the bottom of the Mariana Trench, another 10,000 meters, is made in absolute, perpetual darkness. It is a darkness that has been unbroken for eons, a Stygian blackness that no ray of sun has ever touched. The only light that ever exists here is the faint, cold glow of bioluminescence, the light made by living creatures. This descent is not just a journey through space, but a journey through different worlds. As one goes deeper, the environment changes dramatically. The temperature plummets, hovering just a few degrees above freezing. The water chemistry shifts, and most significantly, the pressure builds relentlessly with every meter of descent. The sheer volume of water overhead creates a force that is almost beyond comprehension. To truly understand the trench, one must understand this crushing pressure, for it is the single greatest challenge to exploring this abyss. And it is the defining force that shapes every form of life that dares to exist here. The single most defining characteristic of the Mariana Trench is the colossal, bone-crushing pressure. At the surface of the ocean, we experience one atmosphere of pressure, the weight of the air above us. But water is far denser than air, and as one descends, the weight of the water column overhead accumulates at an astonishing rate. In the Challenger Deep, nearly 7 miles down, the pressure is over 1,000 times greater than at the surface. It is more than 16,000 pounds per square inch. This is equivalent to having the weight of a large elephant balanced on an area the size of a postage stamp, or the weight of 50 jumbo jets stacked on top of a single person. This immense pressure is hostile to almost any form of life or technology that we are familiar with. A human being exposed to it would be crushed in an instant. Most materials like steel or titanium would buckle and implode unless they were engineered to an extraordinary degree. This is why visiting the trench is such a monumental technological challenge. A submersible designed for this environment must be a fortress, a sphere of perfectly machined metal capable of withstanding forces that would pulverize lesser structures. Even the tiniest flaw, a microscopic crack in a viewport or a weakness in a weld, would lead to a catastrophic, instantaneous implosion. Compounding the challenge of pressure is the absolute and eternal darkness. Beyond a depth of 1,000 meters, the ocean is a realm of total blackness. Navigating here is like flying a spaceship through a thick, starless void. Submersibles must rely entirely on their own powerful lights to illuminate small patches of the abyss in front of them. These beams cut through the dark, But they can also be disorienting, revealing fleeting glimpses of the seabed or strange creatures before they vanish back into the gloom. The psychological toll on explorers is immense. To be suspended in such a profound and isolating blackness, miles from the sunlit world, is an experience few can imagine. And then there is the cold. The water temperature in the deep trench is remarkably stable, but it is also brutally cold, typically hovering between 1 and 4 degrees Celsius, just a fraction above freezing. For any machine operating at these depths, the cold presents another set of engineering problems, affecting batteries, electronics, and hydraulic systems. For the creatures that live here, it means their metabolisms must be adapted to run at an incredibly slow pace. The combination of crushing pressure, utter darkness, and relentless cold creates one of the most extreme environments on our planet, a gauntlet that only the most specialized life forms and the most robust technology can survive. For a long time, it was assumed that the immense pressure and total darkness of the trench would render it a lifeless desert. But we now know this to be profoundly untrue. Life, in its infinite resourcefulness, has found a way. The creatures that inhabit this Hadal zone, the name given to the ocean's deepest regions, are among the most fascinating and bizarre on the planet. They have evolved remarkable adaptations to not just survive, but thrive in these extreme conditions. One of the most common inhabitants is a strange-looking creature known as the Mariana snailfish. It is a small, translucent, tadpole-like fish, entirely lacking in scales. Its gelatinous body is a clever adaptation. It is mostly water, which cannot be compressed, allowing it to withstand the crushing pressure with ease. Another remarkable group of animals found here are the amphipods. These are crustaceans, distantly related to the shrimp and sandhoppers we might see on a beach. But in the deep trench, they grow to astonishing sizes, a phenomenon known as deep-sea gigantism. While their shallow water cousins are typically only a few millimeters long, the amphipods of the Mariana Trench can grow to be over 30 centimeters, or a foot, in length. These giant scavengers are the cleanup crew of the abyss, congregating on any food that happens to fall from the waters above, such as the carcass of a whale or a large fish, and consuming it with remarkable speed. The pressure has also shaped life here on a chemical level. The very proteins and enzymes that make life work in our own bodies would be crushed and rendered useless by the pressure in the trench. Deep-sea organisms have evolved special organic molecules, called piezolites, within their cells. These molecules surround the proteins, protecting them from the distorting effects of the pressure and allowing their biological machinery to function correctly. This biochemical adaptation is just as critical as any physical one, a subtle but essential innovation that makes life possible in the deepest sea. It is a world built on a completely different set of biochemical rules. Of course, in the total darkness, many of these creatures have evolved another fascinating adaptation, bioluminescence. This is the ability to produce their own light through chemical reactions. While not as common in the very deepest parts of the trench as it is in the twilight zone above, some organisms still use it. This cold, living light can be used to attract prey, to startle predators, or to find a mate in the endless night. Each flash and glimmer is a message sent through the dark, a sign that even here, in the most remote and hostile corner of our world, life persists in all its strange and wonderful beauty. The story of exploring the Mariana Trench is a story of human courage and technological brilliance. The first chapter was written on January 23, 1960. On that day, two men, Swiss oceanographer Jacques Piccard and US Navy Lieutenant Don Walsh, climbed into a remarkable and honestly pretty ungainly-looking vessel called the Bathyscaphe Trieste. It was less a submarine and more of an underwater balloon, using a huge float filled with gasoline for buoyancy and a small, incredibly thick-walled steel sphere to protect its occupants. Their descent into the Challenger Deep took nearly 5 hours, a slow, nail-biting journey into the unknown. They became the first humans to ever witness the bottom of the world with their own eyes. Their time at the bottom was brief, just 20 minutes. The immense pressure had cracked an outer plexiglass window pane, and though the crew cabin was safe, they made the cautious decision to ascend. But in those 20 minutes, they made a monumental discovery. Looking out of the tiny viewport, they saw a creature swimming lazily by. A flatfish, perhaps a sole or a flounder, about a foot long. This single observation was revolutionary. It proved, once and for all, that complex vertebrate life could exist at these crushing depths. They had traveled to the most hostile environment on Earth and found not a sterile void, but a habitat for life. For more than half a century, no human returned to the bottom. The torch of exploration was passed to robotic vehicles, unmanned probes that could endure the pressure without risking human life. The Japanese probe Kaiko made several dives in the 1990s, and the American hybrid vehicle Nereus explored the deep in 2009. These robotic explorers sent back the first video footage from the bottom and collected samples of sediment and creatures, vastly expanding our knowledge of the Hadal ecosystem. They revealed a world populated by giant amphipods, strange sea cucumbers, and vast mats of single-celled organisms that feed on chemicals seeping from the seabed. Then, in 2012, 52 years after the Trieste's historic plunge, another pioneer made the journey. Film director and explorer James Cameron piloted the Deep-Sea Challenger, a sleek, vertical submersible he had helped design, to the bottom of the trench. His solo dive allowed for unprecedented scientific observation. Equipped with high-definition cameras and a robotic arm for collecting samples, Cameron spent over 3 hours on the seafloor, far longer than his predecessors. His expedition brought the trench back into the public imagination, providing stunning new images and reigniting our fascination with this final frontier. These few brave journeys represent our only direct glimpses into this alien world. The Mariana Trench is not merely a deep hole, it is a dynamic geological marvel, a place where the fundamental forces that shape our planet are laid bare. The process of subduction that creates the trench is a slow but incredibly powerful engine of planetary change. As the dense oceanic crust of the Pacific Plate slides beneath the Mariana Plate, it carries with it water locked within its minerals. As this rock is dragged deeper into the Earth's hot mantle, the water is released. This water then lowers the melting point of the overlying mantle rock, causing it to melt and form magma. This magma, being less dense than the surrounding rock, rises towards the surface. Some of it erupts on the seafloor, creating a chain of underwater volcanoes. Others grow large enough to break the surface of the ocean, forming the arc of volcanic islands that gives the trench its name, the Mariana Islands. These islands, including Guam and Saipan, are the direct result of the same tectonic process that carves out the deep abyss just to their east. The trench and the islands are two sides of the same geological coin, one a place of descent and destruction, the other a place of ascent and creation. One of the most exciting geological discoveries within the trench has been the presence of hydrothermal vents. These are fissures in the planet's surface from which geothermally heated water erupts. The vents in the Mariana Trench are particularly special. Unlike the famous black smoke vents found elsewhere, which spew out dark, sulfide-rich water, some vents here, like the Champagne hydrothermal vent, release liquid carbon dioxide. These are the only known underwater liquid CO2 volcanoes in the world. They are a window into bizarre chemical processes occurring deep within the Earth's crust. Furthermore, these vents support unique ecosystems. Instead of relying on sunlight for energy, the communities here depend on chemosynthesis. Bacteria and other microbes harness the chemical energy from the compounds erupting from the vents, such as hydrogen sulfide or methane. These microbes form the base of a food chain that is entirely independent of the sunlit world. Mussels, shrimp, and snails cluster around these oases of chemical energy, thriving in the darkness. The discovery of these systems completely changed our understanding of life, proving it could exist in the absence of light, a finding with profound implications for the search for life on other planets. Despite the handful of historic expeditions, the Mariana Trench remains one of the least explored places on our planet. We have more detailed maps of the surface of Mars and the Moon than we do of the seafloor in this deep abyss. Every mission that ventures down returns with more questions than answers, opening up new avenues of scientific inquiry. One of the most pressing quests is to understand the full biodiversity of the Hadal Zone. How many species live there? How are they related to life in other deep-sea trenches? Are many of them unique or endemic to the Mariana Trench alone? A major area of research focuses on extremophiles, the organisms that thrive in extreme environments. The microbes living in the trench sediments are of particular interest. They survive pressures that would destroy the cellular structures of normal bacteria and feast on a sparse diet of marine snow, the slow drift of organic detritus from above, and chemicals from the rock below. Scientists are studying their unique genetics and biochemistry, hoping to uncover novel enzymes and biological compounds. These discoveries could have revolutionary applications in medicine, manufacturing, and biotechnology, providing new tools that are stable under high pressure or low temperatures. The trench also serves as a unique laboratory for geology and geophysics. By placing seismometers and other sensors on the seafloor, scientists can listen to the groans and shudders of the Earth's tectonic plates. This provides invaluable data on the mechanics of subduction zones, the places where most of the world's largest and most destructive earthquakes and tsunamis are born. Understanding the forces at play in the Mariana Trench can help us better model and perhaps one day predict these catastrophic geological events, potentially saving lives in coastal communities around the Pacific Rim. Perhaps one of the most sobering discoveries is that our influence has reached even this remote abyss. Studies of the creatures living in the trench, like the giant amphipods, have revealed startlingly high levels of human-made pollutants, such as PCBs, which have accumulated in their fatty tissues. Microplastics have also been found in the deepest sediments, a tragic testament to how pervasive our waste has become. The trench, once thought to be a pristine and untouched wilderness, is now understood to be a final sink for the pollution we create on the surface. This raises urgent questions about the long-term health of our entire ocean planet. The Mariana Trench represents far more than a mere record in a geography book. It is a symbol of the vast, unconquered wilderness that still exists on our own planet. In an age where satellite imagery has mapped every corner of our land and GPS can pinpoint our location to within a few feet, the deep ocean remains a place of genuine mystery and true exploration. The trench is our planet's last true frontier, a realm that continues to challenge our technological limits and expand our scientific horizons. It reminds us that there is still so much we do not know about the world we inhabit. Its importance to science cannot be overstated. It is a natural laboratory for studying the very origins of life and its ability to adapt to the most hostile conditions imaginable. The discovery of life based on chemosynthesis has broadened our definition of what a habitable environment can be, fueling speculation about life in the subsurface oceans of moons like Europa or Enceladus. The trench is a testing ground for geology, a place to understand the fundamental mechanics of our living planet, and it is a treasure trove of potential biological discoveries that could lead to breakthroughs we can barely yet envision. The continued exploration of the trench is therefore not just an adventure, it is a vital scientific endeavor. It helps us to understand the interconnectedness of our world, showing how events in the deepest sea can be linked to the geology of our continents and even the pollutants we release into our atmosphere. It provides a baseline for the health of the global ocean, acting as a deep repository that records the changes happening at the surface. By studying the trench, we are, in a very real sense, taking the pulse of the entire planet. And so, the Mariana Trench will continue to beckon. It will draw the next generation of explorers, scientists, and engineers to its dark, silent depths. It holds secrets about the formation of our planet, the resilience of life, and perhaps even our own future. It is a place of profound humility, a chasm that puts our own existence into perspective. The great, dark, crushing void of the Mariana Trench is not an empty space on the map. It is a vibrant, dynamic, and essential part of our world, a final, magnificent mystery waiting patiently in the deep.